If you've ever stared at an AWS security group that clearly allows your traffic but packets are still getting dropped, this video is for you. The answer is almost always NACLs, and specifically, misunderstanding how stateful and stateless firewalls interact. I'm going to break down exactly how security groups and NACLs work, how traffic flows through both layers, and the one rule you must add to every NACL to avoid silent failures. Let's start with security groups. A security group is a stateful firewall that attaches to an elastic network interface, or ENI. Not to an instance, to an ENI. That distinction matters because one EC2 instance can have multiple ENIs, each with different security groups. Stateful means the firewall tracks connections. When you create an inbound rule allowing TCP port 443, the security group remembers that connection. The response going back from your instance on some random ephemeral port, say port 52341, is automatically allowed. You don't need an outbound rule for it. Security groups evaluate all rules at once. There is no ordering. If any rule matches, the traffic is allowed. And here is a critical limitation: you cannot write a deny rule in a security group. It is allow only. If you need to block a specific IP that falls within a broader allowed range, security groups cannot help you. Now NACLs. A network access control list is a stateless firewall that operates at the subnet boundary. Every packet crossing that boundary gets evaluated, inbound and outbound independently. Stateless means zero memory. When an inbound packet arrives on port 5432 and you have a rule allowing it, great, it passes. But when the response leaves on ephemeral port 47892, the NACL doesn't know or care that it's related to that allowed inbound connection. It's just another packet that needs its own matching rule. NACL rules are numbered and processed in ascending order. Rule 100 is evaluated before Rule 200. The first rule that matches determines the outcome, allow or deny, and evaluation stops. This is completely different from security groups where all rules are evaluated simultaneously. I number my rules in increments of 100 or 10, leaving gaps so I can insert new rules later without renumbering. Rules 50 through 99 for deny rules, 100 through 199 for application traffic, 200 plus for management access. Here is where most people run into trouble: the ephemeral port problem. When a client connects to a server, the client uses a random high port as its source port. The server responds to that random port. With security groups, this is handled automatically by connection tracking. With NACLs, you must explicitly allow that return traffic. Let's trace a real example. Your web server in subnet A needs to query a database in subnet B on port 5432. The web server picks source port 48756 and sends a TCP packet to the database on port 5432. First, the NACL on subnet A checks the outbound rules. You need a rule allowing TCP to subnet B's CIDR on port 5432. The packet crosses to subnet B. The NACL on subnet B checks inbound rules. You need a rule allowing TCP from subnet A's CIDR on port 5432. The database processes the query and responds. Now the response, 330 to 430, let me walk you through the debugging sequence I use every time someone reports connectivity issues. Step 1. Check VPC flow logs. Filter for reject entries in the last 10 minutes. Flow logs tell you traffic was rejected but not which layer rejected it. Step 2. Verify the security group rules on both the source and destination ENIs. If the security group should allow it, the NACL is your suspect. Step 3. Pull the NACL rules for both subnets involved, the source subnet and the destination subnet. Check both inbound and outbound directions on each. Step 4. specifically look for ephemeral port rules. If they're missing, that's almost certainly your problem. Let me share 3 production patterns I use everywhere. First, keep NACLs simple. Use them only for explicit deny rules, blocking known bad IP ranges, preventing lateral movement between subnet tiers. Let security groups handle the granular allow logic. This minimizes the ephemeral port headache. Second, the quarantine NACL pattern. Pre-create a NACL that denies all traffic in both directions. When incident response identifies a compromised instance, swap the subnet's NACL association to this quarantine NACL. The instance is instantly network isolated. This is faster than modifying security groups across multiple ENIs. Third, always reference security group IDs instead of CIDR blocks for internal service-to-service traffic. When auto-scaling adds instances or IPs change, the rules update dynamically. Before I wrap up, the most important things to remember. Security groups are stateful, allow only, and evaluate all rules simultaneously. NACLs are stateless, support deny rules, and evaluate in rule number order. Always include ephemeral port rules in NACLs. And remove the default allow all egress rule from every production security group. A compromised instance should not have unrestricted outbound access. Tomorrow in day 7, we take everything from days 5 and 6 and build a fully secured VPC from scratch. If this was helpful, subscribe and I'll see you there.